Common sense tells us that if something is on fire, we'll see it. Big, orange, flickering flames. It's the universal signal for stay away. But what if I told you the most dangerous fire in the world looks like absolutely nothing? You could walk right into it. You could be breathing it in, and you wouldn't know until you felt your skin blister. Today, we're figuring out the physics of the ghost flame. Welcome to DailyFigured. To understand an invisible fire, you have to understand why fire is usually orange. Most common fires are dirty. Wood, candles, even campfires produce soot, tiny particles of unburnt carbon. These soot particles get so hot they start to glow. This is called incandescence. You aren't actually seeing the fire. You're seeing the trash it leaves behind. Sometimes color is a signature. Copper turns a flame green. Strontium makes it crimson. Potassium creates a pale purple. This happens because electrons are jumping between energy levels, releasing specific wavelengths of light. In a standard fire, color tells you exactly how much energy is being released. Red, 600 degrees Celsius to 800 degrees Celsius. This is the coolest part of a visible fire. You see this in smoldering embers or the very outer edges of a forest fire. Yellow, 1,000 degrees Celsius to 1,200 degrees Celsius. This is what we call standard fire. It's bright because of incandescence, tiny bits of unburnt carbon glowing like a light bulb. White, 1,300 degrees Celsius to 1,500 degrees Celsius. Now the energy is intense. You see white in the heart of a furnace. At this point, the material is so hot, it's emitting almost all visible wavelengths of light at once. Blue, 1,400 degrees Celsius to 1,650 degrees Celsius plus. This is the peak of common combustion. It's the hottest part of the flame because the fuel is burning almost perfectly. So, if blue is the hottest color, what happens when a fire reaches 2,000 degrees Celsius? This is methanol. It burns so efficiently that it produces almost zero soot. In 1981, at the Indy 500, a pit crew looked like they were being attacked by ghosts. They were covered in methanol fire that the cameras couldn't see. They were literally burning in broad daylight. It's hotter than the blue core of a candle and more intense than a white-hot furnace. But because the reaction is so clean, it leaves no trash to glow. Hydrogen takes this even further. Because hydrogen has zero carbon, it is physically impossible for it to produce soot. Its flame emits light almost entirely in the ultraviolet spectrum. Since humans can't see UV, you could walk right into a 2,000-degree hydrogen torch and never see a single spark. We're taught to trust what we see, but in the world of physics, the most powerful forces are often the ones that leave no trace. In science, a clean reaction is the goal, but a clean fire is a terrifying one. Stay curious, watch for the shimmer, and we'll see you in the next one.